right, lesson 8, last one. Your learning target here is that you'll be able to interpret a linear graph representing real-world situations. So just to get us started, when we're talking about y equals mx plus b in real-life situations, you might see y represented by something like it's your range, it's your output, your dependent variable. If we're talking about items, it might, or money, it might be like your total, or the charge, your total value, your total cost, total amount of revenue. It's this thing that it's where we're going with our function. Your slope has been talked about as your rise over run, or using your slope formula. It is your rate of change. It could be, when we're talking about speed, it could be talking about like your miles per hour, dollars per pound, dollars per month or hour. It is that rate at which things are changing, your unit rate. And then X is your domain, or it's the input, your independent variable. So it's what is going into a function and changing to cause your Y. So we talk about it in terms of like time. Time will always be an X. Your mass or your volume, a distance, whatever is being changed. And then B, your y-intercept, I always think about it as a starting point, whatever our situation is. When we were talking about the redwood tree, our y-intercept then was when that tree was planted, the moment it was planted. When we were talking about the watermelon juice, then it was the amount of money that old Billy Bo Bob had before he had sold anything. So it was his debt. It can also be thought of as like a registration fee or an installation fee or a flat rate. So flat rate being like, how much do I charge initially before any other fees occur, an initial fee. You'll see all of these kinds of things come into play when we're working with word problems. All right, let's see how this works for an actual word problem. So below is a graph representing the resale value of a car X years since purchased. So the moment you drive a car off of a car lot, it decreases in value because it is no longer brand new. And this graph represents that process of decreasing in value. So first we want to find what the slope is, because that slope is going to be our rate of change, or our change in y over change in x. And since x represents the number of years since purchase and y the resale value, and it's a negative slope, we can write this as the decrease in value per year. And this is where having two tools for finding slope can be really, really handy, because here we have a graph where our scale is going to make it pretty difficult to use the slope triangles. So we might see, okay, well, we have a point right here. Oh, there's Bill. And we have a point right, I don't know, we can pick this one. But because this scale is using decimals, we see our x's are increasing by 1.5 and our y's are increasing by 5,000, but in increments of 4. This is the kind of case where it would be easiest to use our slope formula. So I'm going to, you can pick any 2 points. I'm going to stick with these 2 points, write them out. And upon doing that, I actually changed points, but now I have these 2 points. I have the point 6, 5,000, and 4, 10,000, and then I can use my slope formula to calculate my slope. So I'll call this point sub 2, and I'll call this point sub 1, and then I would say 5,000 minus 10,000 over 6 minus 4. It's going to give me negative 5,000 over 2, which means that my slope is 2,500 negative over 1. What this tells me is that my car is decreasing in value $2,500 every 1 year. Okay, what does my y-intercept to this graph and what does it represent? Well, my y-intercept is where this crosses my y-axis. And so I think some people are still having some struggles with that. Again, this is your y-axis. Your intercept is named after the axis it crosses. So it crosses that y-axis right here. So your y-intercept is right there at the point 0, 20,000. And since y-intercepts are your starting points of things, this would mean that when it was brand new, right off the lot, this was a $20,000 car. Okie dokie. So now we can write an equation for that graph. We want slope-intercept form. So y equals mx plus b. So plug in your y. Y is equal to negative 2,500 x plus 20, there we go, 20,000. So if we wanted to go back to the thing, we'd say our input of years is multiplied by our rate of change plus the starting point or starting cost will give us its value. And so once you have all of those pieces in mind, what they all mean, then we can write a sentence to explain the equation in terms of the problem. And this could be in your own words. What I'm going to say is that every year, a $20,000 car decreases in value by $2,500. Okay, so every year, X, a $20,000 car, B, decreases $2,500, M, in value, Y. So in your explanations, please make sure that Y equals MX plus B is represented, every piece of it. All right, so how would the graph be different if the car lost a value of $1,000 a year? So what if M was negative 1,000 instead of negative 2,500? So the closer to zero a slope is, the flatter the rate of change. So the closer to zero a slope is, the flatter the line. And you might remember this from looking at coronavirus data, especially early on when there was lots of talk of flattening the curve. What that meant was we were trying to get that rate of positive cases down so that our curve would, that slope would become closer to zero. 0 cases per day. Flatten the curve, flatten the line. 0 is a horizontal line. Okay, so since negative 1,000 is closer to 0 than negative 2,500, your line would be less steep. And what would the new equation be if the car lost a value of 1,500? This is just to really drive that in, that M is your rate of change. So if you change the rate at which your car is losing value, you changed your M. So then instead here we would have Y equals negative 1,000 times X plus 20,000. Okay, go ahead and grab those journal problems. Good luck making sense of all the pieces. Let me know how I can help. All right, bye guys.